All right, PFRQ2. PFRQ2. We got Ben and Arthur. Oh, the Ben and Arthur. I love the story of Ben and Arthur. It's the best story.
Why? Because he's poor?
No. Ben and Arthur, they're twins, and they make an investment decisions. It's supposed to teach you a valuable life lesson here. Okay, Ben invested 10 grand in an account that pays 12% interest, and I probably should have put the period there. While Arthur invested 30,000 in an account that pays 12% interest. They both plan to take their money out of their accounts when they are 60 years old. Okay, Ben started his account when he was 20 years old, and Arthur didn't start his account until he was 30 years old. If these accounts were compounding annually, annually, that means the number of compoundings, the n, would equal uno. So, you guys know the formula? You guys remember it? I'll put it up here. I'll put the formula right here. I will tell you right now. Future value equals present value or initial value times 1 plus the rate divided by number of compoundings raised to the n times t. T is in years. What are the number of compoundings per year in this problem? Uno. Right? So we don't care about the n's. All right, so Ben, let's do Ben first. Ben. Let's see, he invested 10,000. And the rate is 0.12, and it's divided by 1, right? So we don't need to write it. And then how many years? P is the initial amount, or
they did it when they were 60 years old.
Oh, 60 years old. So he started when he was 20,
So 40.
and they're gonna pull him out in their 60s. So he let it sit for 40 years.
I think.
Okay, so more simply written, we could have just done this. We could have went 1.12 raised to the 40. All right, we're going to need a calculator for that. Can you guys go ahead and plug that in? I will write up Arthur's.
930,509.
There you go. 930,000. Wow, it's almost $1 million.
509.70.
Yes, I was right. Let's go.
Say 909?
No, 509.
509.70. Okay,
Yes.
so that's the dollars
930.
that he has. Okay, for Arthur, we're going to go 30,000. So he's putting in more, 1.12. 30 years, and then what is his amount?
898,797.
97.66.
96 cents? 97 cents?
66.
60 cents.
66.
Okay. Is it 66?
66. The 6 cents matter.
Yeah, it does.
Yeah.
It means you run it incorrectly, and you're wrong. Okay. Now, in real life, would it matter? No. As a banker, does it matter? Yes.
Taxes, yes.
Okay. I want my penny. All right, so I'm going to box those to make sure my answer is clearly identified. And we're done. Yep, that would be a point right there, and that would be a point right there. Maybe just 1 point for both. I'm not sure. It depends on the whole FRQ. Okay, next. How much money should Arthur have invested if he wanted to have more money than Ben at the age of 60 years? So this is one way you could have solved this. There's multiple ways, okay? This is probably the most efficient way, though. You would take the 930,509.70 cents, and you would say, I want this to be greater than Arthur's initial amount times 1.12 raised to the 30, right? So the question is, how much should he have invested? Initial
At least
investment.
$31,058.
Labeling things is really helpful. Okay, so how do you get the P alone here? What would you do?
You just
Divide by 1.
So it would be 930,509.7 divided by 1.12 raised to the 30th. Good old calculator. What do you got?
31,058.
At least $31,058.
0.48.
Does it matter again?
Okay, so he would have to invest a number greater than that.
So he needs to invest another $1,000 more. $2,000.
Yeah. So it has to be greater than that. Now, could you have said $31,058.49?
No.
Yes, because that would says how much should Arthur should have invested, and so you could say that, and then you could say or more.
Yeah.
Right.
Greater than or equal to.
Right. You could do greater than or equal to. but this answer also works. Both correct. All right, so we got 2 questions left for this problem. Here we go. It says, at what age could Ben pull his money out of his account if his goal was at least $500,000? Provide the exact answer in a common log form and the approximate answer rounded to the approximate whole number.
That's right.
All right, here we go. So he wants to have his future value that he wants is 500,000. Okay, and he invested 10,000, and the rate is 1.12 T. Okay, so we want to know what the T is, right? Yeah. Give me the T, guys. No, I'm just joking. Okay, don't do that, Miss Patey. I divide both sides by 10,000, and I get 50. I have my rate on the other side with the T. Now, how do I get rid of that T? Again, there's different ways to do this. I'm going to just log base 10 both sides because I don't want to do the extra bases. And so when I do that, the T gets to go in front of the log and multiplies. So this is, let me clean it up so you guys can see it. So it'd be T times log of 1.12. And then how do you get the T alone? You divide. So it's T equals log of 50 divided by log of 1.12. Now, quick question, guys. Think about this for a second. That would give me what? It would give me years, right? It'd be years that the investment sits.
So then you'd have to add it on to his age.
Yeah, so we have to add it on to initial age. What was his age that he began?
20.
20. So we have to add this to 20. And this would be
35.
the answer. Now, I would give you a point
If you
for this and for the whole thing. Because this would be finding the number of years since he was 20. But if you were wise enough to add the 20 to it, like his initial age, then you should get another point for that. So that's the true answer, isn't it? Yes. And now, if we want to find the approximate, now here's the problem. If you didn't add the 20, you wouldn't get the approximate answer right. So it's actually worth 2 points almost, knowing that.
I put the actual time the calculator said, and then I also put his actual age.
Okay, so let's before we do the appropriate whole number, can you guys tell me what is this?
54.51926.
No, it's 34.5.
34 point what?
5.
5? That it?
Add 20.
1.8
Yeah, you did 20, so you have
plus
to,
20,
yeah, 20.
and then you have to approximate this, right? So we add the 20 to it, so it would be 54.518. But we have to round it to the appropriate whole number. So that would be, I mean, you're not going to stop right in the middle of his age. It would have to be 55 years
So I got
old. There's your answer for that guy. So this gives you your other point. Wow, that one's worth 3 points. Cool. Okay, last one. This one is going to be the super hard one that I don't think a lot of you guys would have gotten. There's many ways to solve this. Again, okay? I'm going to try to do it the most simple way. But not everybody would see the most simple way right away. Maybe you'll see it after we do it together. If they both left their money in their account, will Arthur's account ever be worth more than Ben's account? Okay? Now, the first thing you'd want to do is figure out how much does Ben have in his account when Arthur actually puts the money into the account.
Oh.
So, wouldn't that be a wise thing to think about? Because what if Ben's money is lower than Arthur's initial amount?
No, because I did the math all the way up to 120 years.
I said that same thing. I got 31,000.
Okay, so this would be wise to have. Okay, so I'm going to take Ben's equation, which is 10,000, and I'm going to see how much he has when Arthur decides to invest. So that's 10 years after he invests, right? So can someone punch that into their calculator really fast? Tell me what you get.
33,1058. So yeah, it's the same answer to B.
Right, 33,10.
31,058. No,
31,058.482.
So it's
Is
the
it
same.
48
as
or? Yeah, it's 48.
It's the same. It's the same.
Okay, so he has that much. Oh, that's actually the same number that we found earlier, huh?
That's why you need to get greater than that.
Oh, that's fascinating.
Oh, yeah, also-
so you probably wouldn't even need to write this. And so when Arthur invests, Ben already has more than he has.
Yeah.
Okay. So now the other question would be, does Arthur's amount ever surpass?
No.
Okay.
Yeah, that's
Now
it.
here's a analysis that would show that.
No.
I would take Ben's, which is 10,000. Well, not right there. Okay, and I want to see if this ever equals
Oh, yeah.
Arthur's.
Oh, we're
So
just
Arthur's
gonna plug
is
in big numbers.
no, that's not what I'm gonna do.
Oh.
Okay, now here's the tricky part. I can't just use t right here because the t's aren't the same. But if I put a minus 10 on this t, now they're the same.
So it's minus 10.
Okay, so does this ever equal this? And so I need to put a question mark here because that's what I'm trying to show. So what I'm going to do is I'm going to simplify it and see if they actually do equal each other. Okay, you guys ready for this? Maybe? Okay, first divide both sides by 10,000. So I get 1.12 raised to the t equals 3 times 1.12 raised to the t minus 10. Okay. All right, so now let's see. How can we see if they ever equal each other? So the next thing we can do is let's divide both sides by
3.
Okay, actually, I'm going to split this up right here so you guys can see what I'm doing. So 3, 1.12 raised to the t times 1.12 raised to the negative 10.
So split it up.
Yeah.
Oh, I see.
Okay, so I've split up that exponent. Okay, and then, oh shoot, look at that. Will this side ever equal this side?
No.
No, because I can divide both sides by 1.12, and then I get this. I get 1 equals 3 times 1.12 raised to the negative 10. And is that true? No, that's not true. They will never equal each other.
Oh, yeah.
Therefore, we can say Arthur's account will never be more
Those cancel.
than Ben's. Where are the points, Pates? All right. 1 point would be this, setting this up and showing it. Okay, that's a great analysis. The answer would follow this point. So if you have the first point, then you can show this point. Okay. So that's, I would say, at least 2 points. That would be worth 2 points.
Yeah.